Hello, students of class 8. Today, from the chapter Fossil Fuels and Alternative Sources of Energy, we are going to study fractional distillation. Fractional distillation separates crude oil into useful fractions. Crude oil is the term used to describe unprocessed oil, that is, oil that has been taken directly out of the ground either on land or under the sea. It is an exceptionally valuable resource. It provides us with a great number of hydrocarbons, some of which are useful as fuels and others are used in the manufacture of many different chemicals and even plastics. However, in the raw form, as a crude oil, it can be viscous, dark colored, tar like consistency, and the different fractions of hydrocarbon must be separated by fractional distillation to be useful. Before we understand how fractional distillation works, we should be clear that a mixture of hydrocarbon with different chain lengths, some being short and some being long intermolecular chains. The longer chain hydrocarbon requires large forces at between molecules, and the longer the molecule, the greater the intermolecular forces, as you can see here. The small molecules have weaker intermolecular force and so will require less energy to break them apart and turn them into gas. They have lower boiling point. The longer molecules have greater intermolecular force, more energy is required, a higher temperature. They have a higher boiling point and will be needed to evaporate this molecule. They have a higher boiling point. Now we can understand how chain length is related to the boiling point of a molecule. Let us look how this method works. As you can see, crude oil is heated up to a higher temperature outside the fractional column. The hot crude oil, now mostly in vapor form, is pumped into the column. The column has a heat gradient and is very hot at the bottom, going cooler as we move up to the top. Even at the very bottom of the column, where the temperature is still high, some longer chain molecules with high boiling point begin to condense back into liquid. These are collected at the bottom of the column. The rest of the molecules starts to rise up the column, making their way through the bubble caps. In each tray, the bubble cap slows down the rate of rising vapor and eventually the vapors get to cool, condenses and are collected as liquid in the trays. Smaller molecules have low boiling point and so condense much higher in the column where the temperature is cooler still. As you can see, hydrocarbons with similar boiling points are collected in the same tray, and this is why they are known as fractions. There are mixtures of hydrocarbons with similar boiling points. Each fraction has some important uses. Some examples of fractions are petrol, useful as a fuel for cars; naphtha, used in the manufacture of chemical kerosene as aircraft fuel; diesel oils, used for vans, cars, and lorries; and Bitumen, a mixture of large chain hydrocarbon used to lay roads. Now at the end of this lesson, we understand that crude oil is a mixture of important hydrocarbons and the fractional distillation is the method used to separate crude oil into useful fractions with similar boiling points. You should understand that small chain molecules are collected at the top of the chamber.
Stay home, stay safe, do it for yourselves, do it for your family, do it for India. Let's break the chain of COVID-19. Hum hum ye kamyab. Jai Hind.